My name is Travis Sweet. I work as a senior technical support engineer at Confluent. I'm introducing the speaker for this session. This is Sherin Thomas. She works as a staff software engineer at Chime, and her talk today will be on 10 tips for enabling discovery and governance. Without further ado, Sherin.
Hey folks, are you all able to hear me at the back? Yes. Sorry, we had some technical difficulties, but we're all set now. So thank you all for joining me today, and I hope you're excited for Current, the next 2 days of jam-packed, interesting sessions. Today, I will be talking to you about 10 tips for enabling discovery and governance. And basically, I want to share some tips that the team and I picked up as we were trying to solve this problem at my company. My name is Sherin. I'm a software engineer in the streaming platform team at Chime. Previously, I've worked at Netflix, Lyft, Twitter, Google. I've been doing all kinds of data stuff for the last decade or so, with a lot of focus on streaming. So I've been active with the Flink community. I've done a lot of talks on streaming Kappa architecture and so on. I'm also what they call a Sunday artist, which means I paint in my free time. And the reason I make these air quotes is because I have a toddler. So, what is free time? Can anyone tell me what they see in that block of images right there? Do you know what that is? So those are all the data tools that existed in 2012. So almost a decade ago. And when I saw it, I'm like, wow, there are so many data tools, until I saw the same image for 2021. Almost a decade later, it has blown up. Like, there are so many tools now that I can barely see the text on these. Like, literally, I feel like everyone except me is building SaaS software. And the point I'm trying to make is now data processing has become more and more easier. Analytics has become really easy. Heck, the awesome folks at Kafka and Flink have even solved exactly once processing for real time in low latency. Now the problem has shifted from that of analytics to just an abundance of data. It's really easy to create new and new data sets, and we find ourselves in a haystack where, finding trustable, usable data is becoming a problem. Most of this usable source of truth data is hidden within a haystack of duplicates, inconsistencies, inaccuracies, and just plain ambiguity. And ambiguity is not good. I read this somewhere in reference to LLMs, but I think this applies to data discovery and governance as well. When in doubt, you can't be wrong. When you need good quality data to drive business insights, you just cannot afford to be wrong. Does anyone here know what Conway's law is? So Conway's law says that the architectures often reflect the communication patterns of an organization. So if you have small orgs doing their own thing, you might come up with a microservices architecture, or if there is more of a cohesion, it might lead to a monolith, things like that. Here in the world of data, Conway's law poses a different problem. So we have our product engineering and analytics, and I haven't seen any examples where they work very closely together. They are often two different organizations. Analysts are consumers of data. They are the ones building business insights. And producers are the ones producing raw data on which you can build these insights. Producers don't know what consumers need. Consumers don't know what producers have. While the data engineer is stuck in the middle playing referee, they are neither the producer nor the consumer. I don't even know what they're trying to do. And we need to make these groups talk to each other. Which brings me to my tip number 1. Bring everybody to the same water cooler. Do you remember those old-timey offices with cubicles and there were water coolers strewn around the office? That's where a lot of interesting conversations used to happen, gossip and context exchange and all sorts of stuff. We need that, but in software form, a place where all the context about data can reside and be passed on to all the stakeholders. When we were researching this for Chime, we had some requirements. So we wanted our data catalog to serve the needs of all of these users. So PMs, execs, engineers, data platform, infra folks. And we wanted to choose a data catalog that could support a range of data artifacts. So tables, pipelines, people, roles. Earlier at the keynote, Sean called data a living and breathing nervous system. That's what data products are today. It's not just tables and files. There are, people associated to data sets. There are roles associated to data sets. The data product is much more than just raw data. We also need lineage to see how data travels through this nervous system, how data travels through your organization. And dumping all the data in one place is not enough either. We need to put organization on top of it. Like a container store for data, being able to organize it by tags, domains, glossaries. And we also want to be able to pull context from documentation, comments, places where actual conversations are happening, maybe Slack. And we also wanted to be able to search, do free-form search to find what we need and find relevant source of truth data sets. A place where producers can put context and consumers can find what they need. At Chime, we chose a Data Hub project to solve this problem for us. Data Hub project is an open source metadata platform that enables data discovery, data observability, and federated governance on top of a high fidelity metadata graph, the nervous system. Acryl Data is the company that is advancing the Data Hub project, and they are the ones helping us enable this at Chime. This is our water cooler. This is the homepage of Acryl, where we can go search what we need. We can see data organized by domains, by platforms. We are able to search by not just free-form search, but also by tags, by glossary terms. Who is it owned by? And my favorite feature is lineage. Acryl and Data Hub supports column-level lineage that can help anybody looking at this graph see how information is traveling at the most granular column or field level. Also, just FYI, henceforth, I might use the words Acryl and Data Hub interchangeably, but I mean the same thing. Tip number 2, choose a data language. Basically, a platform-agnostic way to codify a data model, a schema definition language. At Chime, we use protocol buffer for schema. We use it for serializing and deserializing event data on the wire. We use it for serializing structured data written to data stores and for request response models and so on. The ideal scenario is when raw data is produced, often as events, so like mobile click events. In an ideal scenario, you should be able to schematize on write, so that your schema checks and validations happen right at the source. However, sometimes that is not possible. Even at Chime, we initially started off by firing events in an unschematized way. And when we started introducing schemas, there was a bit of an effort to do the migration. There is an inertia, and migrations are not easy. So the second option is to schematize during ingestion or on read. And here's what we did at Chime. We use segment as an event logger for a subset of our mobile click events. And segment has this thing called a tracking plan. A tracking plan is a way to validate schema during ingestion. Now, when our front-end engineer is introducing a new type of click event, they would go and create a schema in our protocol buffer schema repository. We have a CI/CD hooked up in such a way that whenever a new schema is added or updated, the tracking plan gets added and updated. Now, when they start sending these events, the tracking plan checks to make sure, is this a valid event? Is there a tracking plan that exists for this event? Are the fields correct? And so on and so forth. The only challenge with this is because we are schematizing downstream of where it is produced, you have to keep track of errors when schema validations fail and close the feedback loop and get those alerts and errors back to producers so that they can fix schema issues. Tip number 3, use schema for more than just schema. And this is my favorite. A very cool thing about declaring schema in code is all the extra surface area that you get for free to enhance the capabilities of your schema. For example, you can use comments to add documentation and set context about the schema. You can use annotations to fields or messages to add metadata. Protocol buffer language now supports field and message level options. You can use these field and message level options to describe, the nature of the data. For example, here we are using the message level options to say which team this profile event belongs to, or the alert. We are also using the field level options to classify. We are saying that profile is a type of, is confidential. And the good thing is these message options do not increase the size of the serialized protocol buffer object on the wire, but it gives you so many different handles to do a lot of cool things. This also opens up the possibility to use protocol buffer schema as a declarative language. Tip number 4, keep the logical and the physical together. So, raw data typically originates at the ground floor, or what I call the physical layer. This data can be in the form of structured or unstructured events, logs, database entries, documents. This is not directly usable as it is, so it is processed by someone from D using ETL workflows like Spark or Flink. And through this process, a curated set of data in the form of facts and dimension tables are produced. These fact tables and dimension tables are then used to generate insights, funnel analysis, like revenue numbers, many different things. These insights are typically used by PMs and marketing analysts, maybe execs, folks who are far removed from the raw data, folks who don't know how the sausage is made. However, they are not completely isolated from it. If something goes wrong at the physical layer, the impact can be felt at the logical layer. I just noticed my memberships go down. Did it really happen organically, or was there something wrong with the data? There's no easy way to tell. And this is why it's important to have visibility into what's going on at all layers or at all levels of data curation, even when you're only concerned about the business insights. Keep the logical and physical together. Bring engineers, PMs, analysts, BI folks, everybody to the same tool. Engineers can add context, assertions, data quality checks to the data they produce and own. And technical issues at the physical layer can easily be bubbled up to the logical layers. Visibility increases when everybody is communicating at the same place, one water cooler. This is an example from our Data Hub instance where we were able to create assertions, freshness assertions, on top of our data set. And whenever the freshness assertion fails, so a lot of people, a lot of reports, let's say they have an assumption, okay, I'm building this report under the assumption that I will be getting data, as fresh as 24 hours. But if it fails and things start looking weird in my dashboard, I should be able to see it. So when, as an analyst, if I'm looking at the lineage chart, if there is anything wrong with any of the components upstream, it gets flagged. So we are able to see whether this data is trustable or not. But having everything in one place doesn't have to be overwhelming. It doesn't have to be a situation of too much information. You may group data sets into logical groupings like domains and add tags, and also keep them grouped by platforms so that folks who are interested in finance can look at the finance domain data. Engineers may look at the data from Snowflake and Airflow. Tip number 5, keep the logical and the physical separate. And I completely see the irony that I have already contradicted myself, but hear me out. Data governance is a gnarly problem. Rules of data retention and handling vary so much based on where data lives. Moreover, a data type can exist in many forms, as table, as events in streams, as a visual representation in a dashboard. The most challenging aspect of governance is applying rules and policies consistently across all forms in which data can exist. Also, rules and policies may change. There is a famous saying that all problems in computer science can be solved with one more level of indirection. Every data entity should have a logical model defined in a platform-agnostic schema definition, language, and code, something like protocol buffer. Now, you have this surface area where you can specify data classification or governance rules without having to worry about where it is materialized, whether it's going to a table or stream or both. And you can define rules and policies separately in a central glossary and orchestrate them at a platform level. Let's look at an example. Here's an example where data producers who know their data the best are able to tag or classify their data in schema. If I'm the producer of data, I know exactly the nature of data. I know that name is a personal info. And that's all I need to care about. I don't need to worry about whether it's sensitive, confidential, none of that. Just classify it as best as you can. Then I can pull all this mapping into a central glossary where a central team, maybe a governance team or a central identity in your company, can define how these things map to sensitive and confidential data, and also define policies and rules about it. So I can say that any sensitive data needs to be masked on read when it's read from Snowflake for roles A, B, and C. Or we don't want to retain confidential data in streams. And we can define these rules for every single platform. Now, each platform can define their own rule orchestrator. They can build out their own rule orchestrator, and they have the glossary and the schema repository as reference. They can find out the rules. They can also look at how data is classified and use that information to orchestrate the rules at the physical layer where data is materialized. Tip number 6, crowdsource metadata ingestion. This may seem straightforward, but we ran into some, we had to change course midway because of the way our teams were structured. So initially, when we started working on data discovery project at Chime, the team was solely made up of data platform engineers. As data platform engineers, we were tasked with not just picking the right catalog tool, but we were also wanted to pull in context and metadata into the catalog. The problem is we are neither producers nor consumers of data. We don't know how it is being used or what are the needs of our users. To streamline things, we deployed what is called a squad model. So now, instead of just the data platform team solving this, within the platform, we now have a squad of folks from security, from machine learning platform, BI, governance, and each member brings in their special skill set and perspective. And since then, we have been able to ramp up our impact. This group of data stewards define how the best practices for ingesting metadata. They define how data governance rules needs to be applied. They bring in the context and also help design the metadata ingestion layer. We opted to go into a push-based metadata ingestion strategy because that just helped our crowdsource efforts. So instead of a data platform team pulling information from Snowflake and Kinesis and many different services, each team, we provide libraries and SDK that each team can hook up to their services and CI/CD. And much like log and metric collection. And they can start pushing metadata to our central catalog from day one. We have a central API, a central service, which is a wrapper over Data Hub's API, which hydrates, which adds additional global context. But each library that is embedded into services is custom made for that service with using our SDKs and libraries. And these push metadata through the service into the catalog. Tip number 7, and this is an easy one, but not very easy to implement. Everything must have an owner. No owners, no accountability. As you think about cataloging data sets, make sure to assign ownership from the get-go. And also consider different types of ownerships. A technical owner might be the producer or curator of data. And they may be responsible for adding assertions, managing incidents, fixing validation issues. Folks who are getting alerted when assertions fail. A business owner may be responsible for defining the cataloging strategy. They may be responsible for contextualizing, adding domain information, adding tags, and also maybe adding assertions on key SLAs for the data set. Tip number 8, meet data consumers where they are. We all have too many tools to deal with on a day-to-day basis. If users have to go to 3 different tools to find context, inertia sets in, and it just takes more time to get their job done. Earlier, when we did not have a data catalog tool, Slack used to be that place. Everybody would go to Slack, find a person, ask questions, find what they needed. Even when we got Data Hub, that is still another a separate tool that they still have to go to. A common request that we got from users is, if I'm looking at a chart in Looker, I want to see if there is something wrong. How can I get this information? Acrel helps solve this for us by building a Chrome plugin for Looker. This Chrome plugin pulls in context from the 360-degree pages from Acrel. So if I'm a BI engineer or I'm an analyst looking at a Looker dashboard, I have all the context right there at the click of a button. I don't need to go to a separate tool unless I need to. Tip number 9, shift left. So, shift left is a generic term used across the industry to define an approach where responsibilities are shifted to earlier in the software development lifecycle. This is commonly used in the data quality, in the testing community, where they say that by shifting left, you are moving quality assurance responsibilities to earlier in the development lifecycle. It's a great idea, and I think we should use a similar approach for cataloging responsibilities as well. Shift them to earlier in the data cycle. This means giving cataloging responsibilities to producers. And I don't know if you've realized this but I'm a big fan of schemas and schema annotations and protocol buffer. And as I mentioned earlier in the governance example as well, at Chime we use schema annotations pretty heavily. And schemas are a gold mine of information and metadata. When we brought in Data Hub as our data discovery tool, we wanted to pull all this context into that tool as well so that it is searchable and available with all the other metadata. Data Hub has a rich set of protocol buffer SDKs that allows us to push context from comments, messages, field level documentation, and even annotations to the data set within Data Hub. So, for example, field level options can be pushed as tags or glossary terms or domain. The comments, just comments in code, can be pushed as documentation, field or message level documentation. And Data Hub indexes, adds these to the search index. So now when we search, we can run free-form search and find out everything that we need without going and looking for things in our schema repository. Moreover, annotations can also be ingested as glossary items. So a glossary is a common definition for to bring everybody at your company on the same page. So this is an example of how search works today. So once we automatically pulled in all the metadata from schema into Data Hub, into Acrel, we are now able to do free-form search based on comments that people wrote in their code. Tip number 10, and I saved the best one for last. Dun, 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 data contracts. Whoever has been, involved with the data governance, discoverability, data quality community must have been hearing this term for the last few months. Data contracts is the new hot topic on the internet. But what is data contracts? To explain that, first, let me bring you back to the first slide where we established why discovery and governance is hard. The root of most of our problems is a disconnect between producers and consumers. Data contracts adds a formal agreement between producers and consumers where one didn't exist before. Think SLAs. In this world, consumers add assertions and producers own accountability for any assertion failures. Throughout this presentation, we already talked about a few key components that, when put together, can make a data contract. But let's bring it all together. First, a schema, and this is bread and butter. For any SLA, a basic level of validation of the data model is required. But that is not sufficient. We also need semantic validation. This is where data quality checks becomes important. There are many data quality tools like Anomalo, Monte Carlo, but Data Hub is also moving towards that. They are building a control plane for data, and they have already started using some of their features for assertions, like freshness assertions and some data quality checks. But whatever tool you pick, think about how you can streamline assertions and allow producers to move really fast and create them while they are defining the contract or while they are defining the schema. Again, coming back to using schema as a declarative language. The other component of contract is accountability, because without accountability, no matter how many SLAs you set, none of this matters. And lineage can surprisingly be an important component of accountability. It gives producers a view of how data is used downstream, bridging the gap that used to exist between producers and consumers. And lineage can be used for impact analysis, even at the column level. This is something that we have been playing around with, trying to leverage, where whenever someone makes a schema change, we want to ideally notify them of the impact of these changes through a CI/CD workflow by traversing the lineage graph. A lineage graph also gives consumers a lot of visibility because they can be notified of any upstream changes that impact them. So using lineage or for impact analysis for accountability is a really, really good tool. So there you have it, folks. To recap, the 10 tips for enabling discovery and governance. Bring everybody to one water cooler and choose your water cooler well. Choose a common platform agnostic schema language. Use schema for more than just schema. Keep the logical and physical together. Keep all the context in one place, but also keep the logical and physical separate. Add levels of indirection and decentralize when you have to. Crowdsource metadata ingestion. Everything must have an owner. Meet data consumers where they are. Shift left or empower your producers to catalog from the get-go. And finally, embrace data contracts. Thank you for your time. You can find me in all of these social media links, and I'm also here for any questions.